Part 2a4c3m1b7c8e13c9c6d3p38d19d7a. Line 22f1fa19c3m1b7c8e13c9c6d3p38d19d7a. These numbers getting longer and longer and longer. Distributed Bragg Reflector formula, 5G Wow Seti. We got another formula. Okay, so there's the alien radio signal. And we'll just back that up there. So this is going to be a research of keywords for wavelengths, the Bragg Reflector formula for a UFO spaceship long distance communication device found in the WOW data. So we got some more stuff coming up for that. Today's March 21st, and I started working on this one March the 9th, 2013. So I'm going to give you a list of the videos where the keywords came from, and then we'll get into the formula. Okay? So the keyword is Hertzian dipole. It's going to continue from previous video, line 22f1fa19c3m1b7c8e13c9c6d3p38d19d1. Hertzian dipole loop patterns, 5G Wow Seti. Formulas from the data found in this video and in the previous video are in line 22f1fa 19c3m1b7c8e13c9c6d3p38d19d2 Hertzian dipole magnet transformer, 5G Wow Seti. So I started Googling the keywords dissipation, lambda, and then ferrite rod. We went through dissipation in several different ways, and it says we're going to be the keyword lambda, and we finally got there. Isn't that nice? I've been saying that for the last 4 videos, haven't I? Okay, so from previous video, line 22f1fa 19c3m1b7c8e13c9c6d3p38d19d7a Hertzian Monopile Pillings, 5G Wow Seti. So our keyword's lambda. So this is a quote from Wiki. It says, in crystal optics, lambda is used to represent the period of a lattice. So we're working on a mesh lattice for a communication device, so I thought that was cool. So then the keyword distributed Bragg reflector came up. Quote from Wiki, a distributed Bragg reflector, DBR, is a reflector used in waveguides such as optical fibers. It is a structure formed from multiple layers of alternating materials with varying refractive index, or by periodic variation of some characteristic. That's all you can tell. It's spring out here. You can hear 100 birds out there talking. I don't know where they're coming from, but there's lots of them out there, and they're just chattering away like crazy. Such as height of a dielectric waveguide, resulting in periodic variation in the effective refractive index in the guide. Each layer boundary causes a partial reflection of an optical wave. For waves whose wavelength is close to 4 times the optical thickness of the layers, the many reflections combine with constructive interference, and the layers act as a high-quality reflector. The range of wavelengths that are reflected is called the photonic stop band. Within the range of wavelengths, light is forbidden to propagate in the structure. March 12th, formula from the data. Distributed Bragg reflector, waveguides, optical fibers, structure formed multiple layers. Alternating materials, varying refractive index, periodic variation, height, dielectric waveguide. Variation, effective refractive index guide. Each layer boundary causes partial reflection, optical wave. Waves, wavelength, close, 4 times, optical thickness, layers, reflections, combined constructive interference, layers act high quality, reflector, range, wavelengths, reflective, photonic, stop band, which I'm going to Google. Range, wavelengths, light, forbidden, propagate, structure. Keywords will be in the next several videos will be photonic stop band plus constructive interference plus dielectric mirror. Keyword dielectric mirror I'm going to look at in the next video. Thanks for watching.